Hello, this is part 3 and the final part of AI-powered ESG and financial reports insights agent that we created as part of Google Hackathon. Now, just a quick recap. In part 1, we gave you an introduction about this agent and how it works and the workflow, and also the architectural diagram. Then in the second part, we have shown how to set up, how we did the data collection, and how we have initialized the parameters, and how we have configured the project. Now, the main part of the entire of this project, we started with object table, where we created referential data for the files that are saved in the GCS buckets. We are processing 52 files, and on an average 300 pages on an average for each file, which comes down to around 12 to 15,000 pages of data. Now we have used ML generate, and we have shown how we have in the part 2 we showed you how we showed and explained how we can give the prompt, so it gets the required data information from the text, tabular, and image data for each PDF file, and that is 52 PDF files, and it gets all the financial information from all of those files. Not only financial, ESG information. So if the report is ESG, the context is here. If the report is ESG, it should get the sustainability data. That if it is a financial annual report, it should fetch the financial data. Then we are also asking and making sure that the prompt and that the generated text includes metric information for revenue, assets, and then the water recycled, consumed, and some of the ESG related data, metrics, numericals. Then we cleaned that data so that we are having we are not having a JSON format, but a proper format, but it remains in an unstructured format only. That's what we are showing you here, that although we are curating the data for the response text that we received from the generate text function, the data still is unstructured. We are not removing by curation, we are not removing any of the unstructured data. It is still in a unstructured format, but just that we are parsing or fetching it from the original ML generate text results, where you are having this saved in as JSON format. We are fetching it from here and saving it for more readability in another column called response text. This response text we run on the response text. We can run AI.generate and get any analytical logical questions that we want the processor to answer for us, and we have explained and shown you how it actually helps us getting very detailed answers, not only just the numerics, but also it is able to analyze the question and get the required information. Like, for example, how is the foreign exchange risk managed? It means that the processor actually has to go into the PDF file and look for it to answer this question, analyze the data and answer this question. And so likewise we are having many other questions here which are more theoretical, and some of them requires a broader understanding of the data. Like, for example, is a company expanding geographically? This question cannot exist as it is, answer cannot exist as it is in the PDF, so it has to go to the PDF file to understand whether the company is really expanding geographically and where. So it's able to say that it is from US, Germany, China, and Japan, based on the information that is provided, that is existing in the data. Now a lot of data quality has to happen, but we did some basic data quality checks which we showed again in the part 2 of our video. Let us go to the part in the current part 3. We want to show how the generate table performs on top of the same response text. Here generate table extracts the metrics information. We are asking it to get for us direct values, numerical values for revenue millions, net income millions, and total asset millions, and the scope, GH emissions, all of this. These are a set of questions that metrics, that data that we are asking it to fetch. Now that's what then we showed you in the part 2 how it gets the information in like under 40 seconds. This metrics table is just one curation layer on top of the question results that we got here. We are just doing a little bit of cleaning here and like about the annual and sustainability report type and the date format that we are asking for, fiscal year date format, and a few other small things here, but nothing, we are not doing any major changes on the existing data, just a couple of formats that we want so that we are able to project the metrics properly when we are doing the visualizations. Now so if you run this one, it will actually generate the metrics table that will look like this. Now here you can see this is our metrics table. We are having, okay, we can also show the same over here. Here if you run this is how the metrics table looks like, and then we are having the annual reports, sustainability reports, and then if it is an annual report, it will skip getting the information and over about the scope and others, because this is very specific for ESG. And then we want the sustainability to focus only on metrics that is related to sustainability and skip any data that is related to finances. So if you see sustainability for GlaxoSmith here, others, it will skip all the financial questions and will focus only on the scope 1, scope 2, and few other ESG related questions. Then we did that for all the 52 files. I have given 40 here, but it does all, the entire metrics table is generated for 52 files. Using this metrics table, which is all numericals and exactly what we want, we can now project this on plots. That's what we did here. We have analyzed this. Now the good part of this collab is we are having some features, very interesting features, like create we can create plots and graphs right here, suggest some of the charts, and it does a pretty good job on that, where it will generate some text, some quick plots for us to evaluate and understand. And it also requires a lot of efforts from our side to see whether the work that it did is really good or not, but this is something that the collab helps us to do. Now we use the collabs features to do the generate code with DF also. Data frame here, in our case the data frame is this actual data frame. This is only for display. So the actual DF, on top of that DF, we have asked the collab itself again to use the collab features to auto generate code for us, and the code it did generate was the subtask reasoning, and it generated the code like this. And then now when you run the code, for example this one, where we are asking it to plot revenue millions for all the companies in one graph, and okay, so now you can see it projects. We have excluded the GlaxoSmith here only because the currency of GlaxoSmith happens to be UK currency. So in order to make meaningful comparison, we have only chosen the US companies here, and this is the comparison, and for the revenue comparison across the companies. Now like this, we can do several plots and graphs using this metrics table. Now using the same metrics table, we can also do a forecast, because we have data. We have the generate table was able to fetch data metrics information for from 2020 all the way till 2024, 5 years or 6 years of data. So we have used AI forecast tool as part of which is part of the BigQuery. We can also use ML forecast. The ML forecast requires training, but this AI.forecast does not even require the training. It directly understands the data behind and probably does the training using the model times FM. This is the only model that we can use using the AI forecast. Now if you run this one, it generates the forecast table. That forecast table you can now use. Now it generates the forecast table, which is here. This is the forecast table that it generates, and it looks like this, where you get the information about forecast time and all the company, what is the forecast value. We have asked it to project revenue, so it was the forecast, it forecasts the revenue for the next 5 years. Now that it should do for the next 5 years is here, that it has to do for the next 5. Now once you get that data, let me go quickly. These are so many other plots that you can use to fetch data for not only for revenue, but if you run this one, it will fetch data for the total assets, and it will look very similar to the other one. We will run that in a minute, but before that we want to show you the forecast plots. So if we run this forecast plots, this is the forecasted data frame, right? So if we run this, I'm going to run it first for just the Pfizer. If you look just the Pfizer, this is how it is projected for the next 5 years. Then if you look at we can use now here, we can use this. There's just direct plots that we have without any big frames or anything, but now BigQuery GCP provides BigQuery big data frames which got an inbuilt plotting of the graphs, where I think back in the backend it uses the MATLAB, but you can use this one as well to simply forecast whatever you need. Like, I wanted it to generate the forecast for all the companies in one place. So this is what we did using the big frames. Now this was how we used the big frames plotter to get us the required project the forecast data about for the next 5 years, like 2025 onwards to 2029. How does it look based on the current revenues that it generated from the last 5 years. Now not only we are able to do that, I want to also quickly run two other plots that we have, but like for example, using the same metrics table that we generated here, which was generated using the generate table. Using that table, metrics table, we can also look for the total assets. Okay, and then similarly we can do not only for assets, we can do total cash flow in millions, and so many other metrics, so many other plots that we can graphs that you can plot from this table. This table, like I said, got generated by using the generate table feature, the generate table feature. So one more time we want to go to show you the process here. So it is now total complete process is easy to understand. Using the GCS files, now we created the object tables. From the object tables we have used the generate text to connect to the data in the PDF files. 12,000 pages of PDF files were analyzed, curated just for the JSON formatting. Then the unstructured data in this curated table. On top of it, we applied the generate to get interactive theoretical analytical questions answered. Then we also used the AI generate table to get some metrics information. On that metrics information, like revenue, millions, assets, cash flow, equity, dividends, and emission 1, emission 2, scope data and everything. And we can use this table to do normal any visualizations, or we can use this table to create another forecasting table on top of which we can again have visualizations. That is what we have shown you in our working model. This is the final part of our project, and we have also created some Looker files. Looker Studio, we have used the Looker Studio for navigation, but it is part, we have kept it in our as our link here. This you can see, and we can, lot of work is still pending for improving the quality of the data and so many other things, but this is all what we have been able to do as part of this hackathon. Thank you very much for the opportunity.